Alright, so welcome to our discussion today. Today we're going to be talking about the quantum mechanical model of the atom using an analogy of an apartment complex. So when we talk about the quantum mechanical model of the atom, remember that we talk about our energy levels, our sublevels, and then our orbitals. Okay, so going from bigger to smaller, we start with energy levels, then sublevels, then orbitals. You could say that the energy levels are like the floors of an apartment building, that the sublevels are like the apartment types, and that the orbitals are like the rooms in an apartment. So first things first, let's change this to grayscale. So now that we have it in grayscale, let's go ahead and label our energy levels. So of course we're going to start at 1 at the bottom and go up to 7 at the top. Okay, so we have 7 energy levels. Okay, now on the first floor, you got to figure that there's a lot of empty space because there's the lobby, the leasing office. There may not be a lot of room for actual apartments. So on our first floor, we're going to put what we would have as our smallest type of apartment, our lowest energy type of sublevel, and we're going to make sure that it's pretty small. It can take up very little space. So what we put there is what we call the S-type apartment, which would be the equivalent of our S sublevel, which is a 1-bedroom equivalent apartment. Okay, so S would be our sublevel, bedrooms would be the number of orbitals. So we're going to continue that analogy. Just remember that as we go through. So on our second floor, we have more space, so we're able to put in a second type of apartment on the second floor, but we still don't have the entire use of the floor. Maybe there's like a community video center or something on there. So we put in our S apartments all the way throughout because, of course, this is a very small type apartment, very easy to fit on every floor, so we make sure that we put it on every single floor. So what we're going to do for floor 2 is we're also going to put in the P type of apartment, which is a 3-bedroom. Okay, so we put that on level 2, and you know what? That still doesn't take up too much space, so we're able to put that on every floor above it as well. Okay, now we get up to floor 3, and again, we still don't have the entire use of the floor, but we have more of it than on level 2. So we want to put in a new apartment type, and of course we want to make more money, so we want a more fancy, more expensive apartment. So we put the D-type apartment, which is a 5-bedroom apartment. So we're going to go ahead and put that on level 3, and you know what, since we still have 4 levels above it, and the other levels don't have any restrictions on their size, let's go ahead and put the apartment on every single level above it. So now we've got that done. We go up to level 4, we still have space that we can use. So we want to put the most awesome, luxurious, coolest apartment ever, which is an F-type apartment with 7 bedrooms. Okay, so our F-type apartment is huge. Okay, so we can fit that on level 4, and we can also fit it on the levels above it because now we have all that space. Now, in this building, they sell the apartments based on their rent. So there's 2 things that could make the rent be more expensive, and consider the higher the rent, the higher the energy level. So there's 2 things that could increase our rent or increase our energy level. The first one is how good the view is. Okay, so you know, a view can really sell a place. So if you're on the 7th floor, that's gorgeous. The rent for the 7th floor S apartment is probably going to be way higher than the rent for the S type apartment on level 2, right? But here's the other thing. Of course, when you have more bedrooms, it's going to cost more. So there comes a point where it actually costs less to get the better view than it does to get more rooms in your apartment. So for moving on up, like I said, they sell them in order of rent. So of course they sold the 1S pretty easily. 2S, 2P, no problems whatsoever. 3S, 3P, they sold those guys pretty easily too. But now it came to the point where it starts to be an issue of whether the height is going to be more expensive than the number of rooms. As it turns out, it's better to, the 4S was actually cheaper than trying to sell the 3D. So they sold the 4S, then they sold the 3D. Okay, But now that we saw the 3D, now we can come back up to level 4 and sell the P. But again, we're coming up with the rent, so the rent being more or less expensive, turns out that the 5S is the next less expensive. Then back to the 4D, that would be the next most expensive. Then the 5P, then the 6S, then the 4F, D, P, S, F, D, P. So as you can see, you start out when you go from P to S, then DPS, then DPS, then FDPS, FDP. It's a spiral, a very specific spiral, and this is, the reason that we do this is because of the energy levels, the cost of the apartment, if you will. So basically this is something that you need to kind of use the analogy in your mind, but you also need to bear in mind that you need to follow the spiral. You probably need to use a pattern. So let's say that we walk into one of these apartments, not our typical one-bedroom apartment, you know, your 1S apartment, because that's only going to have one room in it, so there's not much interesting there. But let's say that you go into your 2P apartment, right? So we said a P-type apartment, it's got 3 bedrooms, right? So we've got 3 bedrooms in our P-type apartment. Now let's say that you're rooming with some friends, okay? So you guys need to know what room is whose, or even those of you with siblings might be familiar with this, where you may have argued with your siblings over who gets what room in the past, okay? So because of those reasons, we need to distinguish which room is which. So the way that we do that is we walk in our front door. Every time you walk in the front door, what you're going to see is something like this in your P, D, or F, okay? So in your P-type apartment, the first thing that you're going to see is one door straight ahead, and then you'll have one door on your left and one door on your right, because you have 3 bedrooms in your P-type apartment. So when we say in this analogy that we have 3 bedrooms, remember those are your orbitals. So we're always, whenever we walk into a P, D, or F, we're always going to have that one door straight ahead, and then your other rooms will be to your left or to your right. So since we like to distinguish things and we like to use a pattern that's nice and simple, what we're going to say is that that room straight ahead is the 0 room. Just like on a number line where you start in the middle and 0 is in the middle and it's your starting point, we're going to use 0 as our starting point. Now on a number line, when you move to the left, it's negative. When you move to the right, it's positive. So we're going to do the same numbering system here. You got 3 rooms, right? So you have room 0. To our right, we're going to have room +1, and to our left, we're going to have room -1. So this is the same way that we number our orbitals. The middle will be 0, and then we'll build outward +1, -1, +2, -2 on the sides, okay? So if we had, say, a D-type orbital, or a D-type sublevel in this situation, a D-type apartment, we would have another room on both the left and right. So if you were to face the door, the main door, you would see 0. To your right, you would see room +1 and then room +2. To your left, you would see room -1 and then room -2. If you were to go into an F-type apartment, you would see straight ahead the 0. To your right, you would see room +1, +2, and +3. To your left, you would see rooms -1, -2, -3. So basically that balances out. Now we can take this analogy even further and talk about the Pauli exclusion principle. Each of these rooms, let's say, can hold 2 people. Now let's get back to that analogy of your rooming with your friends. Now if you have 2 people who are really good cooks and really terrible about cleaning, they're probably not going to get along very well for very long. They may love each other's food, but sooner or later somebody's got to do the dishes. It's the same sort of thing with electrons. You want to make sure that they have spins that balance each other out. Remember, you have upspin and downspin, so you want to make sure that if you have one with an upspin, you need to have one with a downspin in that same orbital. So in this analogy, what you would have is that you would have one good cook who maybe doesn't clean very well, and somebody who's really good at cleaning but doesn't cook very much. They balance each other out. Now remember, in this situation, we're also going to be talking about how we fill our orbitals. There's a Pauli exclusion principle, which is that they need to have opposite charges because they can't exist in the same space, and then the Hun principle, which means that we fill each room one at a time. Now imagine that you're living in our p orbital and you've got 4 friends, okay? And you can fit 2 people per room. Well, of course, 3 of your friends are going to rush in to get 1 room each right away, right? Nobody wants to be the one who has to share a room unless they have to. So you wouldn't see a situation where room -1 has 2 people, room 0 has 2 people, and room +1 is empty. You would see one where, you know, friend 1 goes into room -1, friend 2 goes into room 0, friend 3 goes into room +1, and then friend 4 has to figure out which room to go into. You will always see them sharing. Okay? So I hope that this clarifies some of quantum mechanics for you. This can be a very confusing topic, so if you have any questions, please feel free to contact me.